Good morning, everyone. Welcome to introducing Korifi, the evolution of Cloud Foundry on Kubernetes. My name is WebDave. You may as well sort of me as Dave Walter. Beside me is Andrew Wittrock, both software engineers at VMware. So you may be wondering, what is Korifi? Well, Korifi is a Greek word meaning peak or summit. So now you may be wondering, well, what is Cloud Foundry Korifi? Well, Cloud Foundry Korifi perhaps is best described by quoting our original vision document. We envision a Cloud Foundry on Kubernetes that provides the same convenient developer outcomes that Cloud Foundry delivers today via Bosch. At the same time, operation and administration of CF on K8s should conform to Kubernetes practices and should converge with cloud-native approaches for providing the developer outcomes that CF addresses. So what does this mean in practice? Well, on the one hand, it means re-implementing the CF API in order to maintain compatibility with core CF CLI commands such as CF push. On the other hand, it means using tools such as custom resources, webhooks, and role-based access control instead of porting bespoke components such as CAPI and UAA over from CF on VMs. It also means leveraging more of the Kubernetes ecosystem. Where project or technology from Kubernetes and other cloud-native ecosystems has demonstrated widespread adoption and operational maturity, we want Korifi to integrate with it as a replacement for a CF subsystem. This in turn means using defined interfaces, which has the added benefit of providing modularity for users. For example, using the Gateway API will allow users an alternative networking solution such as Istio instead of using Contour. Where a suitable interface did not already exist, we've created our own. As you'll see later, the app workload, build workload, and task workload CRDs that we've created allow users to bring their own build and run solutions while retaining the core implementation of the CF API. Lastly, it means allowing users to choose between the Cloud Foundry API and the Kubernetes API when they need to interact with the platform. We envision that platform operators will especially like the ability to declaratively manage resources such as organizations, spaces, and users. So how have we gone about implementing these lofty goals? Unlike CF deployment, Korifi does not include a relational database. Instead, it uses the state stored in custom resources on the cluster to keep track of the desired configuration and the actual state of the resources. Since the resource model differs in Kubernetes with namespace names, early on we needed to find a solution to adapt Cloud Foundry concepts. Our approach centers around aligning the mutability of fields in both models. Resources deployed to a CF VMs platform generally have a visible name, which users can change, and hidden GUID, which they cannot. However, Kubernetes enforces uniqueness in a resource's metadata name. Changing this metadata name results in a new resource being created. We therefore decided to use the Kubernetes resource metadata name to store the GUID and introduce a display name field in the spec to store the user-provided name. We use a lease mechanic to enforce GUID uniqueness across all namespaces and prevent concurrent changes. Korifi uses namespaces for orgs and spaces. It uses a top-level or root CF namespace to hold resources that are common to the entire platform or possibly duplicated to org and space namespaces. When combined with the unique resource metadata names, this allows us to retrieve a resource by GUID regardless of which namespace it exists in, which is very important for CF API requests. Authentication makes use of standard Kubernetes authentication under the hood, which also allows us to use Kubernetes RBAC for authorization. The CF CLI reads your user authentication information from your local kube config and includes it in the authentication header when making requests. Korifi uses pod selector labels to retrieve staging and running logs, aggregating them into a single source for the CF API. By default, this is best effort. Out of the box, logging sidecars are not included, but if a platform wishes to persist logs, a logging solution such as FluentD, Splunk, or Elastic can be deployed alongside Kubernetes. Services conform to the Kubernetes service binding specification interface, or duck type. First, a service instance resource, which references a secret for credentials, is created. Once that exists, a service binding resource is created that links the instance to the application. The application-specific credentials are stored in a secret, which is then injected into the build workload and app workload environments via the vCap services variable. The last and possibly most important items to cover here are the CRDs themselves. The first one is the CF app that's get created as part of the CF push workflow. This is used to store information such as the application's name, desired state. It also drives the creation of a secret to store user-provided environment variables. The status of the resource surfaces information about the state of the application, such as whether it's finished staging. Next in the CF push workflow is uploading the source package. These are stored in the image registry as a single layer image. The CF package resource is created to associate this image with the application and to provide a GUID for the CF API. Once the source is uploaded, staging occurs, and CF build is created to orchestrate this process. This is where the user-provided configurations for things like the memory and disk requests and lifecycle information are combined with the package. There we go. No, I went too far. The CF build is reconciled into a build workload resource, which is the first of our interfaces, integration points where users can bring their own builder, instead of using the built-in Kpack builder in Korifi. This includes all of the information required to allow an application to be staged and should provide feedback on the build and the resulting droplet via its status. Once the application is finished staging, a CF process resource is created for each process referenced in the application manifest. This is where user-provided information for things like the desired number of instances, memory and disk quotas, and health checks are combined with information about the staged application. Each CF process resource is reconciled into an app workload resource, which is the next of our integration touchpoints. This allows users to bring their own runtime instead of using a stateful set, which is the default built into Korifi. It includes all of the information required to allow an application to be run and should provide feedback on the status of the running application. It's also possible to run tasks related to an application. These are represented by CF task resources, which are linked back to the parent application. They include the command the user specified for that task, which is then executed using the application's stage droplet image. The CF task reconciles into a task workload, which is the last integration touchpoint. And again, this has all of the information required for someone to implement a task runner instead of using the default that's built into Korifi. For routing, we have two resources, CF domain and CF route. The CF domain, we've barely scratched the surface. All that we have here is shared domains. So the CF domain is a very simple resource that just has the name of the domain that you wish to set up. We haven't yet implemented logic to protect from like overlapping domains and hostname squatting and that sort of thing. On the routing side, we have basic routing of resolvable host names to application processes. It's possible to map multiple applications to the same route, but we don't yet support path-based routing. So far for services, we only support user-provided service instances. So the user will create, just when they run CF cups, that will create a CF service instance. That will include the name, the type, and the tags of the instance. The credentials will go into a secret that's referenced in this resource. And then similarly for the service binding, that binds the instance to the application. And both of these conform to the Kubernetes service binding spec by including a reference to the secret in the status. So that way we're conformant there, and we can use implementations of that as a runtime. Lastly, we have the dependencies and the core resources that Korifi relies on. By default, it would use Kpack for staging, the Kubernetes service binding spec that I mentioned. We just have a very simple stateful set runner for runtime. The reason we chose that was because Cloud Foundry applications expect an instance index, and stateful sets give us that predictable number for each instance of the application. For ingress, we integrated with Contour. We have plans to use Gateway API, but that's not really not ready yet for stable workloads, and so we're holding off on re-implementing the interfaces there. We use Cert Manager for internal certificates, and also require metric server to retrieve metrics from pods. At this point, I'll hand it over to Wittrock to talk about installation and configuration.
Sure.
Oh,
Can you all hear me? Cool. All right. So if you've been following recently, you'll notice that we switched the installation from using Customize to Helm, and that was sort of generally because we felt the experience was a little bit better. So if you install now, you'll be using Helm. So it's a standard Helm chart, provides a simple interface for users to provide all the configuration options. Of note, all sensitive values are provided via references to user-managed secrets, so you don't have to worry about some of that being stored in strange places. And next up, I hope people like demos. Oops, let me go back. So demos are always entertaining because if they work, it's great, and if they don't work, well, we'll find out. Hopefully this can be... It should be fun because I won't actually be able to see the screen too well. But yeah, cool.
Yeah,
so, cool, all right. So if I can look at this.
Yep.
Cool, looks good. So that's the demo script, right? Cool. All right, so first we're going to deploy Korifi. I've already set up all the dependencies for a kind cluster. So it's a local cluster with a local registry. Didn't really feel like dealing with too many network issues here, so this should deploy Korifi. On the right pane, we will eventually see some resources popping up as we push the various bits, but right now it's just kind of saying I haven't found anything. So, as that works, let me switch down here, get K9s working. Oh man, okay. That's not perfect, but whatever. I can keep making it smaller. Can everyone still read what's going on? Sort of? Okay, cool. Okay, so it looks like, I can't read. Dave, you want to help me? Okay, cool. So if we have a Korifi deployed, and it looks like we do, you can see on the lower pane, there's some various resources in the Korifi namespace. Those are all of our controllers and everything. So I should be able to log in. And of note, right here, you'll see two different choices for auth. One of them is a Kubernetes admin. So that's like literally your cluster admin. We don't really want that. We want our own user, which is the CF admin, which has the resources that we expect. So if we do that, we can then see, I believe we're targeted. All right, and then I think it says deploying Spring Music. Is that what it says? Okay, so we're gonna push Spring Music, and we're gonna hope for the best here because of network. But as we push that, we should be able to see resources popping up on the right, which those are the various Korifi-based resources, as well as some like build images from Kpack and whatnot. And as that pushes, we can probably look at some resources down here. So we've got our pods, I think. Yep. So we've got a build pod going. This is Kpack, so it's using build packs to build the image. You'll see we have an app. We have a build workload, and that should have some various information on it. If we go down, there's a spec, I believe. So you can see various status info and all that. it looks like Kpack is doing its thing, I believe. Might take a few minutes because I don't know if anyone's looked at Java apps recently when you have a JDK and a JRE and Maven or Gradle and everything else. It's a little bit of time, but so far so good. If there are any resources anyone really desires to look at right now while we wait for this, I can look at them. I don't know if, put your hands up, or Dave, what do you think? This might take a few. We can,
the fan's going, so that's definitely the same.
yes, my laptop's taking off. Okay, so we see several of these have completed, several containers. But I know when I turn my head, it kind of cuts out a little bit. Sorry about that. Getting closer. But yeah, so generally on the right side, the bottom are some of the Kpack stuff. You can see the image.kpack and build.kpack. Then you have above that the build workload, CF build, CF package, and the app. So they're not aligned linearly, but you know, at least there's some consistency to the grouping. We can see in the streaming logs that it's still going through its build process. And getting there. Sorry, I should have brought my own internet. I'm used to sitting at home with, you know, a gigabit connection, so we'll get there. I could dance a jig, you know.
Is it worth looking at just going through the CF app, CF package, CF build, or you're almost there now, I think?
I mean, we could.
Maybe make the font if you can maximize. You can zoom in on a particular frame, right?
Ooh, yeah, I don't know about that. There's probably some status down here. Yep, tells it. No, my Tmex skills are not really the best, so advanced zooming in on single frames probably not going to be part of the demo today. I feel like it's so close. Oops. I'm going to step down so I can see for a second. Still compiling? Fun times. It's going. We're seeing more stuff. So it'll get there. Apologies for all the slowness of the building.
In hindsight, picking a smaller.
Yeah, I mean,
That's fine.
2020.
Yeah.
But one more container completed. We're getting there. So,
It's just making the image.
yeah. So we should get there soon. This will all hopefully be worth it in the end when we have this beautiful application running. Any thoughts? What do you want to see? Pardon? I haven't noticed it to be super slow, but most of it is usually network for me because you've got to pull down the various, like for here, you know, the JDK, the JRE, any of the other build tooling. That's usually the bottleneck in my observations, but I don't know. What about you?
Yeah, can't say I've noticed it be particularly slower than, but we haven't done side-by-side comparisons to be sure, so.
I feel like it's so close. Apologies, I have to walk around because.
If you're going to stare at it, then.
Yeah, I mean, it's like a kettle. You watch it and things happen, right? That's the old adage.
Do you want to take any questions while?
Yeah, we can do some questions right now if you all would like. I assume that's possible, and I haven't. Oh, sorry. So the question was, could you load the JDK and the JRE off the file system? And I assume that would be possible. I have not looked into it. Do you know?
No, I haven't looked into either.
Yes, as long as it is recognized as an additional build. Yeah, Kpack should cache it. This is a pretty clean cluster, so I guess I could have pre-warmed some things, but then it wouldn't be the whole like process of me installing everything.
The thing is, it says it's saving an image, and it's just stopped.
This is super fun. Like I said, demos are great because when they work, and when they don't work, you get to watch me squirm. Okay, what is it doing? Let's look at some logs.
Which just says saving local registry.
I can't see what I'm typing.
No, I mean, that's all
That's
fine.
fine.
Yeah. It's having trouble interacting with the local registry for some reason.
I mean, we can try pushing it again and see what happens. I don't know if that's worth it. Oh, boy. Okay. Well, we can keep waiting for it. I can retry it. But theoretically, what should have happened is this application would have come up, and then I would have been able to show you actually binding a service to it. But that relies on the application actually working.
Are there any logs on the local registry itself?
I don't know which one that is.
The one below the red one.
Yeah, let's look at some logs. Did our registry go boom?
I mean, that's just web requests. Weird.
Fun, fun, fun. Okay, should I kill it and try it again?
Yeah, I would. It's going to go through a bunch of stuff that you can skip.
Yep. Hopefully faster this time.
Oh, it's rebuilding images, of course.
Yep, of course it is. Okay, so let's take some questions in the minutes while I try to get this thing working. Again, apologies for the trying to do a live demo. But any questions right now that people have?
Please raise your hands. I can hand you the mic so that it's audible to our virtual audience as well.
How do you handle the application? Are you using stateful sets so that you can tell it the application index instance?
Yep, exactly.
Yeah, that's exactly correct, because in Cloud Foundry, you have indexed instances, and that concept maps to stateful sets in Kubernetes. If you can get around not using indexes, you can use deployments or something else. But we decided to sort of stick as close as we could to the Cloud Foundry concepts right now to make sure everything works as people expect it to.
Cool.
Hi.
Excellent.
Do you plan to support the OSB APIs for service consumption?
Can you say it again?
The open service broker APIs, do you plan to support them?
Right now, we don't have a lot on the roadmap for that. I would assume we're going to try to support anything that is, well, most of the things that are in the Cloud Foundry ecosystem and VMs. We have pretty limited implementation for like service broker type stuff right now. So hopefully to come. And if anyone would like to contribute, then please help.
Yeah, I think that's fair.
Yeah.
I suspect it's the actual local registry itself.
Yeah, and I don't really have time to rebuild the whole cluster.
No, I know.
I can try recording this later and sending it to you all, but, you know,
The joys of a live demo.
yep. It's doing something.
Well, it's still compiling at the moment.
Yeah. Any other questions right now? And yes, I will actually record a demo and try to send it out to everyone, because I feel like I haven't given you the full experience.
What would a offline deploy look like?
Like an air-gapped environment, something
Yeah.
like that? Right now, obviously that's not something that we support. You would need to solve those problems that we've seen earlier, like you would need to be able to load all your build tooling in from a local machine rather than reaching out. So it would probably require a bit more implementation, especially around any build pack stuff. But beyond that, I don't think it'd be too difficult.
I mean, yeah, really, it's about relocating the images required.
We've got some friends that might know.
Yeah.
The build packs fully support an offline deployment, so you can basically rebuild the build pack images with all of the dependencies baked into the image itself. So then the actual Kpack cluster, when it goes to actually run the build, it just copies things like the JDK or the JRE directly into your application image, rather than downloading them over and over again from the internet. So all of that on the Kpack side, fully supported, offline builds, completely capable. You just have to include the correct build packs when you install your cluster.
And at that point, it's just relocating all the images onto a registry that you can access from your environment and rewriting the references in the templates at that point.
So I think we're definitely hitting limits of network stuff, because the previous build finally completed and uploaded, but now I'm outside of the scope of the demo script.
Oh, it finished. And,
Yeah. I can sort of manually open.
Interesting, because that's a local registry. It should not be that slow.
Yeah, well,
I just
Nope.
leave it.
any other questions? You can still continue. Oh, man.
We'll do that.
This looks really fantastic. Where's my mouse? It's somewhere.
There you are. Type the magic, this is unsafe. Okay.
Oh, the next one's coming in, so I got to know healthy upstream. Fun. Okay. Well, you know, this is a demonstration of what can absolutely go wrong in a live demo. Don't be me in the future, because it feels great, let me tell you.
Yeah.
Yeah. So again, I can actually record like screen cap a demo for everyone, and then send it over to Chris, and we can get it uploaded for people. Because when we have a new one, we have 2 minutes. This is perfect. Wait, and then what are you? Is this seriously? Okay.
Screensaver kicked in.
Yeah, I guess so. Okay, cool. Okay.
Hey!
It looks pretty bad. Let me see if I can get an album in here really quickly. I'm going to do this super quickly. I can't type. And then hopefully, if y'all want to, you can stay through the extra few minutes. Wow, this is some advanced stuff. Okay, so if this is here, it goes there. It's not persisted if everything restarts, right? So if I were to go to pods, that's not what I wanted. Which one is it?
It's the build pod, so it should be, not the build pod,
this one.
it's that one, yeah.
So if I kill it off and it restarts, we'll notice that this goes away, or it will once it restarts. So,
Yeah.
no longer there, and I apologize for hurrying now, but you know, y'all saw what happened. So yeah, we want to connect a database. We can do that. Oh, this is, yeah, just reopening the thing. Let me, okay. So we want to connect to database, so we create a database deployment with a service and the whole bit. And then we want to create a service instance, so that's a user-provided service instance. And we're going to bind it. I believe we have a service binding now.
That's restarting, I think.
Yep, and then we have to restart it, obviously, for that to take effect. Hopefully this has been at least entertaining. It might do one more cycle, I don't know. Let's look at it. Okay. So now if we try to add that again, and bear with me as I painfully mouse around.
I love that it's the name of the app.
Why this album? I don't know. I asked for an album from a teammate, and they said, do this one. So it should be somewhere in here. There we go. And then if we go over to here and we try to, oh, I'm on the wrong pane. And do that. We'll notice initially, while it's restarting, obviously there's nothing there. So hopefully it will revive. And hooray, it's there. So yeah, I'm glad we actually got it to work at the end. Sorry about that. There's one last thing that might be,
I think it exited, I don't know why.
oh, I got rid of the logs. But I can just pop over to that pane and show you that the logs actually work
That's the
as well. Hopefully I can, I can't. What did I?
Oh, logs. You take the S off the end. Yep.
There we go. So logs work, yay. Anyway, sorry for all those delays and things, you know, live demo.
It's all
But
good.
there it is. It does connect to a database. You can give a user-provided service. You can bind that. You can do all sorts of fun stuff. It does the sort of things you expect it to. And we'll continue developing features, and anyone that wants to come help us, please do.
Yeah, always looking for help.
Yeah. Whoop. And my laptop really loves me, so I think I need to go back to the.
Yeah, the only other thing we had slide-wise was there's just a roadmap. Like I say, upcoming. We want to use the Gateway API once it's reached a level of operational maturity, and then just expanding the Safe API endpoints that we've implemented. If there are things that people particularly want, they can open issues on Korifi or open pull requests on Korifi, or even better. Always looking for contributions. But yeah.
Fun. Yeah, there weren't too many slides, and I kind of screwed it up by switching back and forth between stuff. So, yes.
Any other questions?
We're over time, by the way, but let's
We are?
take them.
Yes. Yep.
Yes, I was doing that in the back now. Yeah.
And what about rolling updates?
Pardon?
Rolling updates like on Cloud Foundry?
Routing updates?
Oh, rolling updates. So, like you noticed, it's not quite there yet because you saw the no healthy upstream. So we still need to implement some of that to make sure that we have full uptime.
I mean, the one thing here was this was all one instance of everything. So when the instance goes down, obviously everything's down. But if you scale up, you can scale up to multiple instances of the API pods, scale up the controllers with leader election, so they can be scaled up, scale the applications up, obviously, and then there will be a configuration to tell Kubernetes to roll the deployment one at a time, or pieces at a time, to avoid everything being down and there being actual downtime during the upgrade.
Yeah, that's definitely a good point. But for the single instance example, we have not implemented anything special to get around that yet.
Okay.
Questions?
No, I think we're good. Your laptop's saying, telling us to be done.
Yeah, my laptop's as exhausted as I am.
Yes. All right. Thanks, everyone.
Thank you so much.